The name of my project is Empirical Formula of Magnesium Oxide by Teresa. My question is, what is the empirical formula for magnesium oxide? The purpose of this project was to find out how much oxygen is in the strip of magnesium ribbon we were given. First, gather all necessary materials including safety. Second, find the mass of the dry, empty crucible and lid, and then the mass of the magnesium ribbon. 3. Coil the magnesium and put it in the crucible, then find the mass of the crucible plus lid plus magnesium. 4. Place the crucible without the lid in the clay triangle in the ring stand and turn on the Bunsen burner and wait until the magnesium lights up. 5. When magnesium lights up, put the lid of the crucible on using tongs. Take it off the clay triangle. 6. Let the crucible cool off to room temperature. Then find the mass of the crucible plus lid plus magnesium again. 7. Finally, the empirical formula of magnesium, oxygen, and percentage error need to be found out. On the 4 pictures it shows the ribbon inside the crucible, the second is the ribbon lighting up, the third one is it cooling off to room temperature, and the fourth one is the end result. Our materials were scale, ring stand, clay triangle, tongs, crucible and lid, Bunsen burner, and magnesium ribbon. Our safety materials were goggles, apron, and heat-resistant gloves. Data: mass of magnesium ribbon 0.67 grams, mass of crucible plus lid 40.5 grams, mass of magnesium plus crucible plus lid before burning 41.17 grams, mass of oxygen 0.07 grams. Calculation of empirical formula: 41.24 minus 40.5 minus 0.67 equals 0.07, and that is oxygen. Magnesium is 0.67 divided by 24. Its mass is 0.028 moles. Oxygen is 0.07 divided by 16 equals 0.043 moles. 0.0043 moles was the smallest one, so we divide each number of the moles by that. 0.028 moles divided by 0.0043 equals 6.7, which equals 7. 0.0043 moles divided by itself is 1. Calculations of percentage error. I subtracted 180 minus 40 and found the absolute value of that divided by 40 times 100, which equals 350, which was our percentage error. Analysis and conclusion. In conclusion, our percentage error was much higher than we would expected. Our percentage was 350% when it shouldn't have even existed. At the end, our teacher explained that the cleanness of the crucible was the cause of the high percentage errors. We concluded that the empirical formula of magnesium oxide was magnesium 7, oxygen 1, when it should have been only magnesium oxide. Application and extension. In the real world, empirical formulas help scientists determine many things. For example, the amount of magnesium oxide that should be given to a person. Magnesium oxide is often used by people who have a magnesium deficiency. Magnesium is primarily used by our bones and muscles. It is also often used to relieve heartburns and/or indigestion.